Hello viewers, welcome to Digital Lessons for Students by Department of School Education, Nagaland. I am T. Pungadi from City King Higher Secondary School, Science Stream, Jatsama, Kohima. I'll be teaching class 12 mathematics. In this session, let's begin with matrices. It's an interesting and an important chapter to score a good mark in the board exams. Matrices. What is a matrix and what are the types and how do we denote everything we'll be learning today. In 1850, J. Sylvester, he put some terms and functions in a rectangular form and named it as matrix. And in 1857, Arthur Cayley formulated the general theory of matrices. Matrices are one of the most very powerful tools in mathematics. It has a wide application. A very important application is finding the solution of system of linear equations. You have already studied in your lower classes how to find the solution of system of equations by elimination method, cross multiplication method, and also graphical method, isn't it? Later on, we will learn how to solve the system of linear equations by matrices. Apart from that, matrices are widely used in genetics, biology, cryptography, atomic physics, statistics, and so on. Okay, let's begin with the chapter here. The topic is matrices. Singular matrix. Plural is matrices. Okay. Matrix. What is a matrix? It's an rectangular array of numbers or functions. The functions may be real or complex. Or in a simple way, we can define the matrix as ordered arrangement of terms or numbers in horizontal and vertical lines. Okay. Let me give you an example for matrix. We can use this bracket or this bracket. We should not use this one. It's wrong. Okay. 2 minus 3 root 2 1 plus I or 0 1 by 2 or x plus 2 1 minus 1. See, this is a matrix. We have the rectangular arrangement of numbers or functions or terms we have here. Usually we denote the matrix by capital alphabets. I'm using it A here. Okay. And here we have elements in horizontal line and also in vertical lines. These horizontal lines are called rows and the vertical lines are called columns. And the numbers or functions present in the matrix is named as elements or entries. Elements or entries. Okay. Here in this matrix, we have 3 rows and 3 columns. 3 rows and 3 columns. 3 rows and 3 columns. So we can write this matrix as a matrix of order 3 by 2. order, 3 by 3. 3 by 3. We can say this is a matrix of order 3 by 3. Always the rows comes first, the number of rows comes first, and the number of columns comes second. Okay. Let me give you another example. 2 minus 1, 0, half, plus 2, 1. Here the number of rows are 2 and the number of columns is 3. So this is a matrix of order 2 by 3. Okay. And in general, we denote this each element as, if you are taking the matrix as B, then we denote it as Bij. If we are taking the matrix as A, then we name it as Aij. See, this A and B are always should be slightly bigger than this I and J. I and J should be written in the lower suffixes. And I is always representing the row number. And J is always representing the column number. We should not change this order. The first one is always row, the second one is always column. Even in the order, first one is the number of rows, the second one is the number of columns. We say this as an element in the ith row and the jth column. This is the element in the ith row and jth column, or ijth element of the matrix A here, and this is B here. Yeah. And if you know the order of the matrix, we can easily find out how many elements will be there. See, 2 rows and columns, so we write this order as 2 by 3. And 2 3s are 6. So there are 6 elements in this matrix. There are 6 elements in this matrix. Suppose if we have 18 elements. Suppose if we have 18 elements in the matrix, then can we find out the order of the matrix? Yes, it's possible. We can find it as, it can be 18 by 1 or 1 by 18 or 9 by 2 or 2 by 9 or 6 by 3 or 3 by 6. What are those? They are the product of the prime factorization. Suppose if a matrix have 5 elements, then what are the possible orders? 5 into 1, or it can be 1 by 5. It means there can be 5 rows and 1 column, and 1 row and 5 columns. Yeah. Then let's see how to denote a matrix generally. Suppose a matrix have m rows and n columns. M rows and n columns. I'm going to write this matrix now. Let us name it as A. Since it's going to have m rows and n columns, it's going to be a bigger matrix. What can be the first element? A11. A11. Because this is the element in the first row and the first column. The second will be first row, second column. Then first row, third column, so on. So how many columns we have? N columns. So the last element may be A1n. Then what can be this? A21, A22, A23, and so on. And the last will be A2n. So if we continue similarly, we get the last row will be AM1, AM2, AM3, and this one will be AMN. And this is a matrix of order m by n. Then how many elements will be there here? Mn elements will be there. Mn elements will be there. multiplying. N can be any number, natural number, and n can be any natural number. If we multiply, we get the number of elements present in the matrix. This same matrix, instead of writing in a bigger way, we can write it as A equal to Aij of order m by n. So, the matrix, the general form, it can be represented as like this or as like this. We have learned what is a matrix and how do we denote a matrix and the general form, all those. Now we will move on to the next topic, types of matrices. Types of matrices. We have 7 types. The first one is row matrix. The first one is row matrix. Now, what is a row matrix? Row matrix. A matrix which has only one row and any number of columns is called a row matrix. Example, 1, -1, 0, 4, 5. See, in this matrix, we have only one row and 5 columns. So this order of this matrix is 1 by 5. And there is another matrix, B, 0, 1, 2. This is 1 by 3. If we see that this 1 is common, as it is having only one row. So in general, we can write the order of the row matrix as 1 by n. Order of the row matrix is 1 by n. The next, we will move on to the next type, column matrix. Column matrix. Now it is easy for us to define what is a column matrix. Column matrix, it has only one column and any number of rows. See, for instance, -1, 0, 2, 5, 3. Here, we have only one column and 5 rows. So what can be this order? 5 by 1. If we take another matrix C as -3, 5, 42, then order of this is 3 by 1. Now it is easy for us to say the order of the column matrix in common. What is it? M by 1. This is the order of the column matrix in general. Then next, we have square matrix. Square matrix, we know what is a square. What is a square? All the sides are equal. But here in matrix, we don't have sides, we have rows and columns. Therefore, the rows will be equal to columns. That is, A equal to 1, -2, 0, 0, 3, 4, 5, -10, 5. Here, the number of rows and the number of columns are equal. That is 3 by 3 matrix. The number of rows is equal to the number of columns. That is, M is equal to N. M always represents the number of rows and N represents the number of columns. If these two are equal, then we say this matrix as a square matrix. We can, in a short way, we can say this square matrix as A is a square matrix. A is a square matrix of order 3. This will do. We don't need to mention the rows and columns separately. A is a square matrix of order 3. If we take another matrix as like this, then here the order is 2 by 2. Then we can call this matrix as a square matrix of order 2. Okay. Now we have a question. If M is not equal to N, then what do you call? It's a rectangular matrix. It's a rectangular matrix. See, like C equal to 1, -2, 5, 1 by 10, 6, minus 1. Here the rows, number of rows is 2 and the number of columns is 3. Here the number of rows is not equal to the number of columns. Therefore, it is a rectangular matrix. Okay. Before we move on to the next type, diagonal matrix, we will see one definition, that is diagonal element. Elements. Okay. Let us take a square matrix. I'll write this time in a general form: A11, A12, A13, A21, A22, and A23, and this will be A31, A32, and A33. I am taking a square matrix of order 3 by 3, or we can say that it is a square matrix of order 3. Okay. If you see these elements, okay, only these elements. Here, these elements Aij, where I is equal to j. See, here 1, 1, 2, 2, 3, 3. But if you see the other elements, it's not same. See, only these elements are having the rows and columns same number: 1, 1, 2, 2, 3, 3. These elements are called as diagonal elements. These elements are called as diagonal elements. And the line, this line is called main diagonal or principal diagonal. Main diagonal or principal diagonal. Okay. So how we define diagonal elements? The elements Aij, where I is equal to j. Those elements are called diagonal elements. The line in which the diagonal elements lie is called the main diagonal or the principal diagonal. Okay. We need this definition for the next type, diagonal matrix. Okay. Now we'll see what is a diagonal matrix. To be a diagonal matrix, first of all, it should be a square matrix. A square matrix. A square matrix A equal to Aij of order, any order, say let's take M. Here, all the non-diagonal elements, are 0. A square matrix A equal to Aij of order M is called a diagonal matrix, in which all the non-diagonal elements are 0. What are these non-diagonal elements? The rest. This is called diagonal elements. The rest are called non-diagonal elements. If these all 0, then we call that particular matrix as diagonal matrix. Example: -1, 0, 0, 0, 2, 0, 0, 0, 5. See, we have the numbers only along the diagonal, not on the non-diagonal elements. Yes. Otherwise, in short way, we can write this matrix as A equal to diagonal of -1, 2, between commas, 5. It means A is a diagonal matrix, and along the diagonal we have -1, 2, 5, and the rest, all the non-diagonal elements are 0. So this is a diagonal matrix. Okay. Next we will move on to the scalar matrix. Scalar matrix. Scalar matrix. A scalar matrix is also a square matrix. Is also a square matrix Aij of order m cross n, in which this Aij takes the value 0 if I is not equal to j. If I is not equal to j, and k if I is equal to j, provided this k is not equal to 0. Provided k is not equal to 0. This k should not be a 0 number. It should be some scalar, any quantity. And what do you mean by this I not equal to j? I not equal to j. It is non-diagonal elements. Non-diagonal elements. And what is this I equal to j? This represents the diagonal elements. Okay. Let's see an example. A equal to -1, 0, 0, 0, -1, 0, 0, 0, -1. It's a square matrix of order 3, and the diagonal elements takes the scalar -1 and the non-diagonals are all 0. So this is the scalar matrix. The next one is identity matrix. The scalar matrix will be called as an identity matrix when these diagonal elements are 1. See, B equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is an identity matrix. The diagonal elements will be equal to 1 and the non-diagonal elements will be equal to 0. So how can we write this? Similarly, Bij is equal to 0 for I if I not equal to j, and 1 if I equal to j. Okay. Usually we denote the identity matrix by capital I. Capital I. I for identity matrix. Otherwise we can call it as unit matrix. I is a unit matrix or I is an identity matrix. This is of order 3 by 3. So we can represent this matrix as I3. If we write I3, what does it mean? I3 is an identity matrix of order 3. Then what is I2? It is an identity matrix of order 2. And I, simple I, that will be identity matrix of order 1. Let me write I2. 1, 0, 0, 1. Okay, then what will be the I1 or I? We can write it as 1. So this is of order 1, this is an identity matrix of order 2, and this is an identity matrix of order 3. So this identity matrix plays an important role in the matrix. It acts like 1 in the real numbers. See how it is useful for us, 1 in the real numbers. Similar way it also works. So it's a very important identity matrix. Then next we will move on to the 0 matrix. 0 matrix, the name itself, it defines what it could be. So 0 matrix, it will have all the elements equal to 0. And is there any rule that it should be of this order? No, it doesn't have any rule like that. It can be of any order. See, it can be like this, or it can be like this, or it can be like this. This is usually denoted by O, capital letter O. O represents the 0 matrix. We can say it as 0 matrix or null matrix or void matrix. 0 matrix, null matrix or void matrix. Okay, that's all. We have the types of matrices. The first one is row matrix. What is a row matrix? It's a matrix which has only one row and any number of columns. And what is a column matrix? It is a matrix which has only one column and any number of rows. And what is a square matrix? It is a matrix in which the number of rows is equal to the number of columns, that is m equal to n. And what is the diagonal matrix? The non-diagonal elements will be 0 and the diagonal elements will be equal to any number or terms or functions. And scalar matrix, all the diagonal elements will be equal to 0 and the diagonal elements will be equal to some scalar, non-zero scalar. And identity matrix, where the scalar will be 1. Scalar matrix is identity matrix, and every identity matrix is a scalar matrix. Scalar matrix will be identity matrix if that scalar is equal to 1, but every identity matrix is a scalar matrix. And zero matrix, all the elements are equal to 0. We can call this as null matrix or void matrix, this identity matrix, or we can call it as unit matrix. Can two matrices be equal? Yeah, let's see. Let us take two matrices, A equal to Aij and B equal to Bij. When can we say that these two matrices are equal? It should satisfy two conditions. The first one is it should be of the same order. They are of the same order. If they are of the same order, that is, if it is 3 by 2 matrix, and this also should be 3 by 2 matrix, or if it is 4 by 3, this also should be 4 by 3. The second one is corresponding elements are equal. If two matrices satisfies these two conditions, then we can say that these two matrices are equal. I'll show you an example now. Let us take A equal to 2, 0, 3, 1 and B equal to 2, 0, 3, 1. First we have to check the order. What is its order? 2 by 2. And this order 2 by 2. First condition is satisfied. The next one, we have to check the corresponding elements. Corresponding elements, same position elements. See, here 2, here also 2. And 0, 0. 3, and this is also 3. And 1, this is also 1. Therefore, we can say that these two matrices are equal. That is A equal to B. Okay. Let me take in another example. 2, 0, 3, 1 and D equal to 0, 2, 3, 1. Are they equal? It is of order 2 by 2 and this is of order 2 by 2. The first condition satisfied. In place of 2 we have 0 and in place of 0 we have 2. And here we have 3, 3, 1, 1. The numbers are same but their positions are not same. See, in place of 2 we have 0 here and in place of 0 we have 2. These two are changing their positions here. Therefore, these two are not equal. So, this A is not equal to B. Okay. Not only one condition, it should satisfy both the conditions. The first one should be of the same order and the second one will be the corresponding elements are equal. Okay. This is done here. I'll show you an exercise problem. 4, 3, x, 5 is equal to y, z, 1, 5. Find the values of x, y, z. Find the values of x, y and z. Okay. How can we find this x, y, z? It's given already. These two matrices are equal. What are the two conditions for two matrices to be equal? It should be of the same order. So, same order and the corresponding elements should be equal. So, using that condition, comparing, since it is given already they are equal, so the corresponding elements must be equal. Comparing the corresponding elements, we get, in place of 4 we have y. Therefore, y must be equal to 4. We got y. And here 3. And here we have z. So these two, if you equate it, you get z equal to 3. And in place of x, we have 1. So this should be equal. So x equal to 1. That's all. We get the values of x, y, z. Using the condition, corresponding elements are equal. That's all. In this session, we have learned what is a matrix and how do we denote the general form and how to find the number of elements if you know the order. And if you know the number of elements, we can find out the order, possible orders, and what are the applications and types of matrices. And we have solved one problem using the equality of matrices. In the next session, we will be seeing the operations on matrices. Thank you.